This is part 2 of the TL494 water heater controller. Took me a while to get back to this. There's another video on modifying the board, and this is how we hook the thing up. The board is extensively modified. It has this resistor going over here, a couple traces cut in here, capacitor added, jumper, and another resistor. And there's a diode that you have to remove. But this is my favorite board for doing this. If you're going to use external FETs, you know, this allows you to select FETs up to hundreds of volts, depending upon your array. What it uses is your existing solar panels. I mean, this could be a standalone system, but if you have panels going to a charge controller, you can add this on to harvest any extra energy that is not used to charge the battery. If you attach it to a charge control, you want to have this option of a diode. This will isolate the capacitor bank from the charge controller, so it won't confuse it or this can provide an awful lot of current. So if it's a PWM model, this will damage the FETs. You always want to connect to they have a thermal switch on the water heaters that are emergency for overheating. Normally you don't like to have DC. Any DC over 30 volts can cause problems with switches, but this will be at about 60 volts. If this should ever open, these capacitors will be at exactly the same voltage, and they'll stay within 20 or 30 volts as this opens up during the time there might be some kind of arc. So this is really safe. So here you have a bank of capacitors. You want to use at least 5. You know, use something decent in size. Capacitors have a current capacity, and typically, I always say most capacitors have about 1 amp of ripple capability. This one is 3.5, but this is a water heater or anything like this is going to be using the capacitors all the time, and they'll age rather quickly. So I like to see at least 5 of them, and it's nice to have around 10,000 microfarads, although you can go smaller depending upon the voltage you're at and what current there is. This is your water heater. The water heater can be 1 element, 2 elements. This can be a skillet if you want. This can be, I use basically the same circuit on a space heater. And in the fall at my camp, I dump extra energy into this heating up a room. You know, it's not a lot of heat, but raising the temperature a couple degrees will take the chill off. So I use an oil-filled type radiator, and those have 2 heater elements. And that you can't touch it when it's connected up to around 60 volts. So here's your 2 FETs. You always want to add this pull-down resistor to the gate. That ensures that the FETs will be off if this board gets disconnected or there's anything wrong. On these, you can buy these Dupont connectors with a male on one end and a female on the other. You plop them together, make sure these exposed pins are on one side, and then you can these are individual, but you can stack them together, and you could glue this, and that makes a nice mounting for the board. You can remove it. And this end, you have these pins that you can solder on to your other connections. These wires inside are very thin. There's only 3 or 4 little thin conductors, and if you strip it and try to solder, mechanically it just won't be strong enough. So these are a common FET I use, an IXFP 110N15. These are 110 amp, 150 volts. These are cheap. They're very common because they're used in a lot of inverters. So that's one choice. You can always add multiple FETs in parallel to these to give you more current. what you're trying to do is you're trying to reduce the on resistance. That on resistance times the current that you expect is how much heat you'll dissipate in the FET. And you'd like to keep that as low as possible. Put the heat in the water heater. Keeps you from having to have a really big heat sink. Now this board has to be powered. We take the power off where the capacitors is. A 6.2K resistor with a 12 to 15 volt center will power this board. It's only about 20 milliamps at most. And if you're going to use a temperature controller, I suggest you get one of these little power supplies. These are less than $2 shipped. It's basically kind of like a wall wart. Most wall warts that you have will work on as little as 60 volts. You have a lot less current, but this whole setup would only take less than 100 milliamps, including this little green temperature controller. This last one I bought, only cost me $2 shipped. Kind of amazing. But they take 10 milliamps at just for the readout, and if the relay comes on, it goes up to about 60-70 milliamps. So if you want to use one of those, I suggest you just use a power supply. We're sampling the voltage of this capacitor, and we use a dropping resistor on this side first to get the voltage down, and then you can have a fine adjustment with this 20K pot. These resistances will change depending on what voltage you want to have for panels. If you do 3 panels and it's 90 volts, this resistance has to be higher. You can calculate this out. It's spelled out in the other document. Now this temperature control, we need a 68K pull-up resistor on this. And the reason this resistance is so high is that you only want to see a maximum about 7 volts on this pin. So when it's shorted, the board will be powered. When it's open, it will shut off, which is a nice thing about sensing here, because if this opens up, immediately it's going to sense a lower voltage and the heater is just going to turn off. So but it's fairly simple. Like I say, if you have a charge controller existing, you can just run right off that with that diode option, isolate it. But you can set this to basically the power point, and your MPPT controller or PWM controller will draw whatever they need to charge the batteries, and any extra will just go over here. This is the system I have at my camp. I'm able to divert about 2,500 watts a day to 2 water heaters. It's a nice setup. I'd have the panels that size anyway, so this is a big savings, and it's really nice to have water that's hot at the sink or whatever. You can do a small water heater or a large water heater. I have some other videos on that. But this is it, and this is looking at the board component side. So this is your pin 1 over here, and this is your pin 6. It's not that hard. If you just study this and some of my other videos, I'm always missing something I'm saying, but it's always in another video. Water heating is a nice thing to do. So thanks for watching.